We've already got a good grasp of programming, so let's put our skills to the test and create an actual game. Wordle is a fun guessing game where you have to guess a 5-character word in just 6 rounds. The game can be broken down into 4 simple rules. First, each time you play, you get a chance to guess a valid English word from the word list. Second, after you make your guess, the screen will show you the color of each character in the word to give you some hints. If you guess the correct word, you win the game. But if you don't guess the word in 6 rounds, you lose. Alright, let's tackle the first rule. We can use the input function to get a player's guess and store it in a variable. To check if the word is a valid English word, we can use a Boolean function as the condition. If it is valid, well, we do nothing. But if it's not, we give the user another chance to input. But what if the user's second input is still not valid? Well, to solve this problem, it's time to learn a new programming logic, the loop. Remember the last episode, we discovered that a condition works by using the jump function. Instead of skipping to the next lines, if we jump back to the previous lines, creating a loop, like repeating buying a ticket over and over again. But most loops should end in a specific condition, meaning they keep repeating until that condition is true. We call it a while loop. Just like in if statement, we use big braces to show the repeating part. If the condition is true, the function inside is executed rapidly until the condition becomes false. In our game, we use a while loop instead of a condition to finalize our logic. Here, we notice that the same set2 functions. To make the code easier to read, programmers often use the do keywords in advance, creating a do while loop. This means the program will run at least once the code inside and then check the condition. Now, the first rule is all set. About the second rule, we can easily do it by using the function. But I'll explain how this function actually works in the next episode. Stay tuned! We've already got a valid input word from the player, and we need to check if it's correct. To make things easier, let's create a constant to store the correct answer because it's never changed during the game. The correct answer is a word. In programming, we call it a string, which we have a peek in the first episode. To tell the difference between a string and a variable name, we wrap it in quotation marks. Now we can use the equal to function to check if the player's input matches the correct answer. If they are the same, hooray, we win the game! If not, we let the player guess again, which means we start another while loop. We are almost there with the game. The last thing to handle is the lose condition. Let's break down with a simpler example. We only need to repeat the process 6 times. We can use a variable to keep track of how many times we already repeat. After each round, we increase the variable by 1, so the loop continues as long as the repeat time hasn't reached 6 yet. In programming, we often use the double plus sign to represent the increase function, which means adding 1 to the variable. Let's see how it works in action. First, we create a counter and set it to 0. Since the condition is true, we enter the loop. We buy our first ticket and update the counter, increasing it by 1. Now the condition is still true, so we repeat for the second time. Just like that, we keep repeating and repeating. And after 6 rounds, the condition finally becomes false, and we jump out of the loop. So we successfully run the loop 6 times in total. Just like that, we can create another kind of loop called a for loop. Since it's repeat 4 certain times, we follow the 4 keywords by 3 functions. Initialization, which run once after the loop, condition, and updation, which run in the end of each cycle. Programmers often use letters like I, J, or K as the name of the loop counter. Now let's apply this to our game. We can use the for loop to replace our while loop, so the player can guess exactly 6 times. But if the player gets the answer in advance, we need to break out the loop first. Just like the swift case statement we learned last time, we use the break function to jump out of the current loop. After 6 rounds, if the player still hasn't guessed the correct answer, they lose the game. Now our game is finished. The code seems a bit long, but in a clear logic. We use a do-while loop to get a valid guess. Use a single function to color the hint. Use the equal to function to check the win condition, and for loop to check the lose condition. Time to wrap up. Loop logic allows us to repeat a block of code multiple times. We can use the jump function to go back to the beginning of the loop after each iteration. With the condition, we introduce the while loop. This loop continues to execute while a specific condition is true. If we need the loop to repeat at least once, the do-while loop will handle it. And if we have a specific number of iterations in mind, we can use the for loop with initialization, condition, and updation functions. One important thing to remember is that we can use the break statement to exit the loop earlier if needed. Now let's talk about something else that's equally important. Creating projects is a fantastic way to reinforce our learning and gain new skills. And breaking down a big problem into smaller, manageable parts makes it much easier to solve. In our next episode, we'll dive into computer memories again and explore arrays and data structures. These concepts are crucial for understanding how the Wordle works. I can't wait to see you in the next episode, Wordle Part 2.